Hello student. So today we will take on some question on dipole moment. So in my previous lecture I have taught that what is dipole moment, how it can be calculated, the basic thing about it. So in this video we will learn about some question. We will take on some question on dipole moment. Now see the first question. First question is explain why one member of each of the following pair has zero dipole moment but the other has. So we have four pairs of compounds are there. So out of this four pair, in each pair one member has zero dipole moment while the other member have some appreciable dipole moment. So we have to identify. Now see that in the pair number 1, okay, in the first pair. So first pair, in the case of first pair, you see that the two compounds are there. One is CCl4 and other is CH3Cl. Now if we draw the structure of CCl4 and CH3Cl, so say this is the structure of CCl4. So this is tetrahedral structure, you know. Okay, this is a tetrahedral structure, you know. This is the structure of CCl4 and this is the structure of CH3Cl. So these are the three hydrogen atoms are there. Now see, in this case, the CCl4, this compound, the CCl4, this CCl4, the shape of CCl4 is symmetrical. Now why it is symmetrical? You see that all the bond angles are equal, all are CCl bond. Okay, so since all are CCl bonds, so all the bond length will be equal and all the bond angle is 109 degree 28 minutes. That means in this structure, in this CCl4 structure, in this structure, all the bond length and bond angle are equal. That means all the bonds are in same environment. So that is why we can say that this structure is a symmetrical structure. So see, and since we know that in case of symmetrical structure the dipole moment will be zero, because in case of symmetrical structure the vector addition of all the bond moment becomes zero. So in CCl4 the mu, that is the dipole moment, will be zero. But here you see that in case of CH3Cl, this is not a symmetrical structure, because you see that here you have two different types of bonds are there. So here you see that the CCl bond and you have three CH bond. Okay, so the bond moment of the CCl bond, the bond moment of the CCl bond cannot be cancelled by the bond moment of the other three carbon hydrogen bond. So that is why in this case this compound will have a non-zero dipole moment. It will have an appreciable dipole moment. Okay, now consider the second case, that is carbon dioxide and sulfur dioxide. Now you see that in case of carbon dioxide the structure is, this is the structure of carbon dioxide, okay, where the central carbon is p hybridized, and this is the structure of sulfur dioxide. This is the structure of sulfur dioxide with a lone pair of electron on the sulfur atom. Now you see that in case of carbon dioxide, you see that the bond moment due to this carbon oxygen bond is acting in this direction, and the bond moment due to the other carbon oxygen bond is acting in this direction. So the net dipole moment of this compound will become zero, because these two bond moment will cancel each other, and as a result of that the resultant dipole moment will be equals to zero. But here in case of sulfur dioxide, you see that the bond moment due to this sulfur oxygen bond, this is acting in this direction, and the bond moment due to this sulfur oxygen bond is acting in this direction. Okay, so and moreover the bond moment, the moment due to this lone pair of electrons, so this is the lone pair of electron. So the lone pair of electron will also have some moment, Okay, so this direction of this can be shown as in this direction. Okay, so that means you see that the three moments are acting simultaneously. So the resultant of these three will be downward, and that means this compound SO2 sulfur dioxide will have some appreciable dipole moment. So the mu will be unequals to 0. Okay, now let us take the third case. So in case of third case, you see that in case of third case, that is BF3 and NF3. So in case of BF3, the structure of BF3 is like this. This is the structure of BF3. And NF3, the structure of NF3 is this is the structure of NF3. This is the structure of NF3. Okay, with a lone pair of electron on the nitrogen atom. Now in case of BF3, you see that BF3 is a symmetrical structure. Because why? Because you see that here all are BF bond. Okay, and since all are BF bond, so the bond length will be equal. Bond length of all BF bond will be equal, and moreover the angle between two bonds, so any bond angle you take, all the bond angle will be 120 degree. Okay, so this is a symmetrical structure. So in case of symmetrical structure, what we know that in case of symmetrical structure, the bond moment mu will be equals to 0. Okay, so here we can say that the resultant of the bond moment of these two bond moment, the resultant of these two bond moment will be acting on this direction, which will be exactly equal and opposite to the bond moment acting in this direction. Okay, so as a result of that, the dipole moment will be 0. Okay, and we can also say that since this is a symmetrical structure, so its bond moment will be equals to 0. But in the other case, in case of the other one, you see that here in this case, here the situation is different. First of all, this is an unsymmetrical molecule. Okay, this is an unsymmetrical molecule, and moreover you see that the bond moments which are acting in this direction due to 3NF bond. Okay, the resultant of this 3NF bond will be acting downward. Okay, whereas the bond moment due to the moment due to this lone pair of electron, this is acting vertically upward in the upward direction. So the resultant mu will be the vector addition of these two moment. Okay, so this will be acting downward. Okay, so this will be the direction of the resultant mu. That means in this case the mu will have a non-zero value. That means this molecule will have an appreciable dipole moment. Okay, now next you see that next is the cis and trans of this molecule. Okay, of this compound. This is the cis and trans form of 1,2-dichloroethylene. Okay, so first we will draw the cis form. So suppose say this is the cis form. Okay, let me draw the cis form first. So say this is the cis form. Cis form means the two chlorine atom will be on the same side of the double bond, and transform, in case of transform, the two chlorine atom will be on the different side of the double bond. Okay, now you see that in case of transform, what happens in case of the transform? So in case of the transform, you see that the bond moment due to this carbon chlorine bond and the bond moment due to this carbon chlorine bond, these two bond moment are acting in opposite direction and they are equal. Okay, so they are equal and opposite to each other, and as a result of that, the resultant mu will be equals to 0. That is the resultant mu, that is the dipole moment of this molecule, will be equals to 0. But in case of the other one, the bond moment due to this carbon chlorine bond is acting in this direction, and the bond moment due to this carbon chlorine bond is acting in this direction. So the resultant dipole moment, the resultant of these two bond moment will be acting in the upward direction. So in this case, the mu is unequals to 0. That means in this case, this molecule will have an appreciable dipole moment. Next question. So next question is between NH3 and NF3. Between NH3 and NF3, which one will have more dipole moment? Now, if you see the structure of NH3 and NF3, so so let me first draw the structure. So this is NH3. This one is NH3. And this is NF3. This is NF3. Now you see that in case of NH3, what happens in case of NH3? You see that the bond moments due to the nitrogen hydrogen bond. Now if you see the nitrogen hydrogen bond, the nitrogen is more electronegative, so here delta minus charge will be developed, and hydrogens are electropositive, so delta plus charge will be developed on hydrogen atom. So the bond moment due to the nitrogen hydrogen bond will be acting in this direction, that is from hydrogen towards nitrogen. So this is acting from hydrogen towards nitrogen, and the bond moment due to the lone pair of electron is acting upward, that is away from the nitrogen. Okay, so that means these four vectors, these three vectors, the resultant of these three vectors will be acting upward, and the moment due to the lone pair of electron, this is also acting upward. So that means the resultant of these four vector will be the sum of these three plus this vector. That means in this case the mu will have some appreciable value. Okay, so it is have some appreciable value. Okay, but in case of NF3, you see that the bond moment due to NF bond, since the fluorine is more electronegative, so fluorine will acquire delta minus and nitrogen will acquire delta plus. So the bond moment due to NF bond is acting in this direction. This will be acting in this direction. Okay, and the resultant of these three, okay, so the resultant of these three will be acting downward. Okay, now due to the lone pair of electron, the moment due to the lone pair of electron will be acting upward. Okay, so the overall dipole moment of this compound will be the vector addition of this and this. Okay, that means the sum of the bond moment will be cancelled. Sum of the bond moment will be cancelled due to this lone pair of electron whose moment is acting opposite to the resultant of the bond moment of the 3 nitrogen fluorine bond. Okay, that means in this case the mu will be reduced because this vector will be cancelled by this vector to some extent, so the resultant mu will be reduced. Okay, so in this case the dipole moment of NH3 will be greater than the dipole moment of NF3. Now the next question, that is toluene possesses dipole moment. Now how can we explain this fact that toluene possesses dipole moment? Now you see that if you see the structure of toluene, so this is the structure of toluene, this is the benzene ring. With the benzene ring, a CH3 group is attached. Now all these position, you know that all these are carbon, okay, and these carbons are sp2 hybridized, and this carbon, that is the methyl carbon, okay, this is sp3 hybridized. Now since we know that if the hybridization state is different, if the hybridization state of a carbon is different, then the electronegativity will also be different. Now we know that higher the percentage of S character, okay, higher the percentage of S character, more will be the electronegativity. Electronegativity will be more. So from that perspectives, this carbon, okay, this carbon will be more electronegative because it is sp2 hybridized, where the percentage of S character is more, with respect to this carbon which is sp3 hybridized, where the percentage of S character is less. So that means this carbon is more electronegative. So if it is more electronegative, so it will draw the bonded pair of electron towards itself. So if it draw the bonded pair of electron towards itself, so this carbon will acquire a delta minus charge and this carbon will acquire a delta plus charge. Okay, that means the polarity will be developed in toluene. Now if there is a polarity, so there has to be a dipole moment. Okay, so there is a polarity, so the bond moment of this will be acting downward from the positive pole to the negative pole. So because of this, it will have an appreciable dipole moment. So dipole moment mu will be non-zero and the compound will have some dipole moment.